So our next demo is showing how we're building self-service infrastructure as code clusters using Kubernetes as a reference case in this. And so we'll show you our Kubernetes pipeline. We're also going to show you how GitOps works for self-service and explain how one of the things that we're able to do is have dev, test, and production clusters, or actually whole endpoints, so we can work on the test process and not break production when somebody's writing new automation. My name is Rob Hirschfeld. I am the new Chief of Platform Operations for bankn.cloud, and I'm just new on the job and helping build the platform team up.
And I'm Greg Althaus, and since it's a bank, I'm Vice President of Platform Architecture. I brought Digital Rebar's platform from RackN into the company. So, Rob, you're back at my desk. What's up today?
We have got something really exciting. One of the teams, the retail team, is ready to expand their Kubernetes cluster. They called me up and they said, we need more capacity, and I've whiteboarded out my solution for you so that you are ready to go. I've made it really easy with this whiteboard. So
I'm gonna take your pens away.
But we're just gonna use Digital Rebar, right? And then we're gonna use Kubespray, so Ansible stuff. I did that in my last job. I'm all set to go. I started building an inventory file.
Okay. Well, yeah, that's how it works. But we already have all the automation, and they already have a content impact. Why don't I show you?
I would love to see it.
Why don't I show you what we've got? Okay, so the retail team, they have 3 endpoints already: a dev, a prod, and a test. And we actually have 3 clusters already running, and these happen to be Kubernetes clusters that they're managing. And so if I go back to my repos, I can see that in the profile definition for their cluster, this is going to use a Kubespray pipeline to deploy Kubernetes. Kubespray is an Ansible-based playbook that allows you to deploy Kubernetes across multiple machines, building standalone, multiple control planes, all kinds of stuff. And in this case, they chose to have a single code plane. And how many machines? They just want another worker node?
They needed 2 more worker nodes.
In dev, or okay, fine.
Well, let's give it to them in dev, and we'll teach them how to do this in prod, because this looks pretty straightforward.
Yeah, I was gonna say they can do this themselves. We've given them all this information, and they can drive this themselves. They have access. So I'm gonna do the same commit.
So there's a GitHub, there's a GitLab hook that's going to catch this commit?
Mm-hmm.
Okay.
So in this case, I've now tagged and updated that repository. So at this point, we have a set of triggers. Triggers are basically ways that the system can be notified. In this case, we're using a GitLab webhook to trigger a notification that a tagged build was done. That generated a work order. Work order is just a collection of tasks that run a blueprint. Blueprint is just a list of tasks that we want to run. This can be scripts, Python, whatever. In this case, it's adding the system, adding the content pack to the tree, and made it available on the manager. At this point, I'm going to help the system a little bit and force the downstream endpoints to immediately catch the update, so that specific retail dev noticed that there was a content pack change, its specific one, and then now pulled in that content. And as a consequence of additional triggers.
So we actually can see exactly what's installed at each one of those downstream endpoints?
Yeah, so that endpoint has all of these content packs installed, and we just updated the retail dev content pack on that one. So it's now up to 1.0.
I'm missing a small detail in all of this. I mean, the hardware component, because infrastructure as code is cool and all, but the discovery of the hardware at the very beginning, or a catalog of the hardware that is available, because you're running a lot of scripts everywhere, but actually, do you know if you have the resources to do it in the first place? I mean, so the guy that asked for the cluster expansion, where are these 3 nodes? Or 5 or 20?
In this case, the cluster is defined to come from a Linode resource. So in that case, the broker in question, well, it's defaulted, into a Linode broker. So it's going to create those resources on the fly. Other cases, the broker might be a pool broker, which says pull resources that I have from physical infrastructure, in which case the cluster build request that's now running on this cluster here, as it's building the infrastructure, would fail and say resources not available, that can't be done. And so then the system would notify that that's the issue. For the cases where we're doing automatic discovery, those resources come up and go into a pipeline that has a stage that says, what should I become? And based upon either rules or external integrations, that machine through the pipeline process figures out what it should become. And then that may drive it to a situation where it becomes a member of a pool. So it's available as a resource for somebody to pull in, or may get automatically added to a cluster as part of its bring up.
So this discovery process, so if I think at, at a classic data center pod with some networking and stuff, so I need also to reconfigure some switches to create maybe VLANs and stuff. So during the discovery, I can also set up all this functionality. So I know there is hardware. I need to configure all the paths to get, my resources available. And so this could be automated.
That's exactly. So the system has a default workflow that when a system is booted, if it's physical, it's going to come through and actually put on a discovery image, do a deep inventory for it. If it matches a profile that we know, we can actually start workflows after that. Or it can just become part of a pool and then take on secondary pieces. But yes, everything we do is focused on this end-to-end automation story. There's times when somebody just boots a machine and wants to, look at it or build an inventory set, and that's a pretty normal use case for us. The thing that we've been adding in the release that we have coming out next week, is actually this resource broker concept, where you can start building separate workflows around these concepts, or a cluster, and have a pipeline that is driving the cluster with actually no physical backing or no virtual backing.
In fact, the resource broker, when I look at it from the manager's perspective, I can see that each endpoint kind of has its own set of resource brokers to operate from. In the case of bringing up the retail dev, it ended up using this Linode resource broker, so that I can even target, potentially for accounting purposes and other reasons, subsections of what I want to bring up and track. Okay.
So the fact that it's called Linode broker is helpful for us, but you could have one for retail, one for dev, one for Joe, one for Sue. It's right. The resource brokers are generic ways to get resources. They're not tied to clouds at all. Matter of fact, in the next demo, we'll talk about how Terraform is one of the agents behind the cloud interface.
And so,
are we going to get to the point where we're going to show how do you do resource quotas, whether they're respected by, whether we set those quotas in the node or the underlying infrastructure provider, and Rebar and Digital Rebar respects that by just returning that the resource isn't available, or being able to set it in Rebar directly?
It's not a key feature in what we're showing in the demo. We would respect the resource components, and the pools actually are a way that you could enforce resource cataloging. We do have some basic cost accounting that'll help you know how much is going in on a resource or a cluster from a spend perspective.
Yeah, so maybe we can talk about it offline, but this whole thing of if the crypto group, I love the previous example, we used the crypto group, and they say, what, we need more than what we paid for. And there's really nothing stopping me from taking more than what I paid for.
One of the use cases that the pools enable is actually to have a much more dynamic resource. And one of the things that we were talking about this use case just for us, because there's a lot of VMs being spun up for this demo, right? You can actually build a timer that says at X time, delete these clusters, right? Greg showed how to delete a cluster, and it would actually release all of the machines, right? The Terraform state files and things like that are stored in the definitions in a secure way. And so what would happen is you could actually say, I'm done with this cluster, or I want to downsize the cluster, put it on a timer, and just make things go. You could actually start reusing hardware in ways that most companies aren't ready for, just because of the politics of the companies, not because of the tech.
So philosophically, how much control does the platform group have versus the consumers?
The platform gives you the ability to define tenants. So if it's a physical resource set, we can make the crypto team not see anything but their specific resources through our tenanting system. With regard to cloud resources, currently the brokers rely on the underlying credentials that are accessing the clouds themselves to enforce the limits in that regard. Because a lot of times those limits are unique to the clouds themselves. So it's easier to just say, here's your ID, and the resources are managed in the cloud itself. And so that's how we handle those kind of.
The nice thing about the way the brokers are designed is that you have, if you had different teams with different credential sets, you could actually put those in different brokers. So there's reasons like what we've done here where every site has the same brokers because it makes the automation more portable. You could also have every site have its own brokers and have their own credentials for that. So there's a lot of different ways to scale this.
Okay, so if I understand that correctly, if I use the cloud credentials petitioning, because I can link that back to billing, that's a way that I could actually make an individual group responsible for their own budget without having to do weird internal integrations into a billing system. Okay, that's
Correct.
kind of cool.
And one thing I want to highlight here from a competitive advantage just in market, because this is software and our customers are managing the software themselves, there's no restrictions on the number of runners you can have. We're not taking their credentials. The customers are managing all that themselves. So we never ask our customers to give up secrets or share data. That's the idea of this all being software.
Okay, so our machines are built. Our cluster is running its workflow to expand the cluster. And so at this point, we can look in and see, here's our Terraform or our Ansible playbook of KubeSpray going through its process. This is going to take quite some time. So we'll monitor it and tell them when we're done, but that's kind of it. That's all they need to do to add those resources.
Well, I can go back and show them how to expand the cluster for production themselves when they're ready to do that.